Question 1. You're given that the surface area of a cube is equal to the total lengths of the cube's edges. So if we just let x be the length of the edge, then recall that an edge is just that thing, or that. So the surface area of the cube can be written as 6 times x squared, and that will be equal to the total lengths of all the edges. So there are 12 edges in the cube, so we just write them 12 times x, and we can solve this equation and we'll get that x is equal to 2, and since the problem is asking for the volume of the cube, then we just do x cubed to get our volume of 8. Okay. Question 2. So we want to evaluate this thingy right here. And let's start out by expanding this. So using this definition, we can write that to be 1 over x plus 1 over 2 1/2. And so this simplifies, this first part can be simplified to 2x with 2 plus x as the numerator. Again, we have a little plus thingy, and we still have x plus 2. And now we can do these together with this. So we will get 1 over 2 plus x over 2x, and 1 over x plus 2. That's okay. So this can be simplified to, just plus 2x over 2 plus x plus 1 over x plus 2. So since the denominators are equal, then we can figure out our answer, and we'll get 2x plus 1. And that is our answer. Question 3. So first of all, we know that there are 118 total hats, and they come in 2 different colors, red or black, and also 2 different styles. So if there are 44 red hats, then that means there has to be 118 minus 44, which is 74 black hats. And we also know that 64 hats have stripes. So that means that 118 minus 64, which is 54. So we know that 54 hats have no stripes. So we want to find out how many black hats without stripes there are. And we also know that there are 33 red hats with stripes. So if there are 33 red hats with stripes, then that means there are 64 minus 33, 31 black hats with stripes. So if there are 74 total black hats and there are 31 black hats with stripes, then that means there are 74 minus 31 or 43 black hats without stripes. Question 4. So we are given a math class that is 60% girls, and the problem states that after G number of girls and 1 boy join the class, then there are 70, well then the class is 75% girls. So let's just first let the original class size be X. So we're gonna set up a fraction, and this fraction is going to be equal to 75% to 75%, and that's going to represent the 75% girls. So that means that the numerator has to be the number of girls, and the denominator is the total, or the class size. So our numerator will be all girls, and the total number of girls is 0.6 times the original class size, and this gets how many girls were in the original class. And then, and then we're gonna add G to that because G number of girls joined the class. So for our denominator, which is the class size, we have to have the original class size plus the number of girls joined and plus the 1 boy that joined the class. So now if we cross multiply, this is equal to 0.75. If we cross multiply, then we will get something that looks like this. 0.75 times x plus g plus 1 is equal to 0.6x plus g. So I'm going to multiply both sides by 100 just to get rid of the decimal, and we'll get 75 times x plus g plus 1 is equal to 60x plus 100g. So now let's expand the left side, and we'll get 75x plus 75g plus 1, plus 75 is equal to 60x plus 100g. Now we're gonna isolate the g and the x on different sides of the equation. So, let's subtract both sides by 75g, and we're gonna move this to here. Okay, basically, you'll get 25g is equal to 15x plus 75. Now each one of these variables is divisible by 5. So let's just divide everything by 5, and we'll get 5g is equal to 3x plus 15. To see things easier, I'm going to take out the 3 to get 3 times x plus 5. So the question is asking for the least possible value of g, for the least possible value of g. And since there's a 3 on this side, then that means g has to be divisible. Well, g has to be a multiple of 3, or else all these other, no, or else then x will be some random non-integer number. And x has to be an integer because you can't have like half a person. So we can use some guess and check. We can first try to see what would happen if we let g be equal to 3. And if g is equal to 3, then we would get, okay, hold on. We will get 5 times 3 is equal to 3 plus x plus 5. So we can cross out the 3 here, and we're left with 5 is equal to x plus 5, and x is equal to 0. Well, that is not possible. So that means g is not 3. The next smallest multiple of 3 is 6. And let's just try that. So we will get 5 times 2 is equal to x plus 5. And in this case, it works because x will be equal to 5, which is an integer, and that is good. So that means that our answer is 6. Last question, question 5. So we want to find out how many arrangements of the letters of trespass will not have an S as the final letter. So first of all, let's find out how many total arrangements there are for trespass, assuming that we want everything to be distinguishable, meaning that all of these S's are treated as the same letter, so they're undistinguishable. So for 8 letters, you have 8 permutations, different possibilities, but you have to divide that by the number of S's, well, that permutations, to get rid of all of the repeats. And that is equal to 672. So, since 5 out of 8 letters, 5 of the letters are not S's, so that means that for the last letter to not be an S, we can just multiply that by 5 over 8, and we'll get 4,200. So that is our answer. There's another way of doing this, and that's just choosing the number of ways to put the S and multiply that by the number of ways to put the remaining letters, to arrange the remaining letters. And that is just equal to 35 times 120, which is also equal to 4,000.